The eagle has landed. Welcome to Maths. This is SIR Mangeya. Right, and this part is on volumes and areas of shapes. How different areas of different shapes and volumes of different shapes. Then after watching this video, please like and share, subscribe to this nice, powerful item. Let's get started. Right, first part, I will start with a triangle. What is a triangle? A triangle is like this. That's a triangle, right? So three sides. How do you find area of a triangle? We have two different formulas that we use to find area of a triangle. Number one, we use half base times height. Half base times, this one is base times height. Where we have the base and the height. Height must always be at 90 degrees or perpendicular to the base. Like in this case, if we are to have height, it can be something like this. This will be height. Then this whole thing is the base. Just like that. That's the first part. Then the second formula, given that we have a triangle like this one, but no height, we can have an angle. There will be an angle like this one. I call this one theta. Then I have these sides A, B. So to find this side can be C. To find the area of this triangle, you use half AB sine theta, where A and B are the sides which makes up angle theta. It's more like if we have these two sides, this angle theta, then we have this one is A and B. If it's like this, then this, if your angle is this one, then these are your sides A and B. If it's like this up here, then these sides are your A and B. So A and B are the sides which makes up the angle theta. Just like that. That's for a triangle. That's for a triangle. Then moving on to the next shape. Parallelogram. A parallelogram is similar, the way is similar to a triangle, however. Right, what is a parallelogram? Is a quadrilateral. A quadrilateral is a four-sided shape. So a parallelogram is a quadrilateral with a pair of opposite sides parallel and equal. So a pair of opposite sides like this. Right, I can have this one, it's a parallelogram. So this side and this side, they are parallel and equal. I can use one mark. Then this side and this side, they are also parallel and equal. This is what is known as a parallelogram. Then how do you find the area of a parallelogram? Right, you can divide like this. So a parallelogram, you can check, is made up of two equal triangles, triangle A and triangle B. These are two equal triangles. And this one is the base of the parallelogram. That's the base. And you can have the height here of a parallelogram. And the height must always be at 90 degrees or perpendicular to the base. This one, the height H. Right. We have two different ways here. If the height is there, is given, then how can you find the area? Right. If you can check, a parallelogram is made up of two equal triangles. So you can say area of a triangle, that's the background, area of a triangle times 2. That's area of a parallelogram. So if we're using the first part, this one, half base times height. So it will be half base times height times 2. Half base times height, then times 2. Then these 2 and these 2 will cancel out. So we'll be left with BH, which is base times height. So area of a parallelogram is just base times height. Then if we don't have height now, maybe we have the angle. Let's say we have this angle that will be given here. Let me remove this one and this part. Still, there will be two equal triangles. We can have this angle given. And this angle is theta, and these sides are A and B. Right? We can say area of a triangle, half AB sine theta, then times 2. Then the same rule applies. 2 cancel out is AB sine theta. That's area of a parallelogram. Just like that. So just know that a parallelogram is made up of two equal triangles. To find area of a parallelogram, you say area of a triangle times 2. Just like that. Right. Then the next one is a circle. Well, let me start with the trapezium. Right. A trapezium is also a quadrilateral, that is a 4-sided shape. And this one is a pair of opposite sides parallel. A pair of opposite sides parallel, but they are not equal. Right. Take note of that part. They are parallel, but not equal. So you can have a shape like this one. Right, so this one is called a trapezium. It can be even something like this. It's a trapezium also. So this one, we have this side and this side are parallel. This side and this side are parallel. These are the sides that we call A and B. There are two parallel sides of a trapezium. Then this one is A, this one will be B. Then you have the height. This one is the height of the trapezium. I can call this height H. Right. So to find the area of this part of this trapezium, you say half the sum of the two parallel sides times the perpendicular height. Half the sum of the two parallel sides times the perpendicular height. So sum is addition. A plus B times height. So it's half A plus B times height. Two parallel sides is A and B. Take note of that part. Is 2 applies here. We have the height. Height is to be this one. So it must be at 90 degrees or perpendicular. This one will be your height. So please take note, your trapezium can be presented even in this way. Still is a trapezium. And this will be your height. And these two parallel sides are your A and B. Please take note. A and B are the sides that are parallel. That's A and B. Right, for a trapezium, we are done. Then next part, we have the circle. Circle is like this. Right, then let me... So this first one, let me label some parts of this circle. This whole thing from this part to this part is called circumference, right? It's called circumference of a circle. The distance right around the circle, that's called circumference. Then if I can shade inside, this part is called area of a circle. That's area of a circle. Then this part is called a chord. This line, the red one, is called a chord. Then if I can draw another circle here, right, then this one is called a diameter. A diameter is a chord, is a special chord that divides the circle into two equal parts. That's called the diameter. Then half diameter is called radius. Then the other part of the circle, right, then if I can shade this part in red, this one is called a chord, a segment. It's actually minor segment. Then this top part is called the major segment. So these are the parts which makes up a circle. Then you can have also this part. If I can draw it this way. So this part that I have shaded, it's a sector. It's a sector and it's a minor sector. And this part on this side, it's a major sector. So how do you find area of a circle? Area of a circle is pi r squared. Where are the radius? Then please take note. Diameter and radius, where the relationship, they are here. Diameter is actually twice the radius. 2 times radius. Or you can say radius is diameter divided by 2. That's radius. Just like that. Right, so area of a circle is pi r squared, where r is the radius. If I give a diameter, then it means you have to divide diameter by 2 to get your radius. The circumference of a circle, that's the distance right around the circle. Circumference is 2 pi r. Or you can say pi d. Pi d, because 2r represent diameter. So it's the same as pi times diameter, which means diameter is 2 times radius. Like this. So you can use whichever, pi d or 2 pi r. Still, it will work. Right, for a circle, we are done. Then sector. What is a sector? Sector is just part of area of a circle. Part of a circle is called a sector. We have center here. Then this part is called the minor sector. If I can separate from the circle, it's like this. This one is radius, radius, then radius, radius, then this one is my sector. Something like this. So a sector is something like, right. Let me remove the auto item. Yeah, but still it works. So radius, radius, right. Now want to shade. Let me shade this one in red. Then this one in blue. This whole part in blue. I have two parts here. The part that is shaded in red and the part that's shaded in blue. The blue one, that's the major sector, and the red one, that's the minor sector. Minor sector and major sector. Let me remove this one. So this one is the minor sector. Then the major sector will be like this. It's like this. Right. That's the major sector shaded in blue. Then the minor sector, that's the one that is shaded in red. Right. I want to shade the area of a circle. Because sector is part of a circle. So if I am to shade the area of a circle, which is pi r squared, how will I shade? I shade based on the angles that they make or form at the center of this circle. So if I can have this one, let me draw another circle. So the angle that they make at the center, like this one, will be an angle theta, which means on the other side, it will be 360 minus theta. Why? Because angles at a point, they add up to 360. So I shade this angle, this area based on the angle. So to find the area of this minor sector that I've shaded, it will be more like ratio. Theta, total angles, they are 360. So it's theta over 360 times area of a circle. Just like that. So it's theta over 360 times area of a circle. This one's area of a circle. That's area of a sector. It's angle over 360 times area of a circle. Just like that. That's area of a sector. Right, take note of that. Then for the major sector, it will be this angle actually. 360 minus theta. That's the angle. But you can just say theta over 360 times pi r squared. Just like that. Right, next part is arc length. Length of an arc. Arc, if I can draw my circle like this, then from this point, maybe to this point, I can say from point A to point B, this one is my arc. How can I find the length of this arc? Right, I have to develop my, right, arc, if you can check, arc is part of circumference. It's part of circumference. Then how do you find, which means arc length is found from circumference. How do you find circumference? You can use pi d or 2 pi r. These two formulas. So which means I have two here arcs. I can say I have this arc here. This part. From the blue side, I can say this one is CD. So AB and CD. These are two arcs. How can I find length of arc AB or CD? I shade based on the angle that they make at the center. Like this arc AB, it makes an angle theta. Then it will be theta over 360 times circumference of a circle, which is theta over 360 times pi d or times 2 pi r. So you can say or theta over 360 times 2 pi r, whichever formula to still work, right? So these are the two formulas for arc length. Now, for perimeter of a sector. Perimeter of a sector. Sector is like this. So perimeter, you say This part is radius, let me put my angle theta. Then this one is the arc. Distance. So you can say r radius, this side plus this side radius plus arc. So it will be r plus arc length. That's perimeter of a sector. So it's r plus arc length. We have it here. Or here. Theta over 360 times pi d. So you can say theta over 360 times pi d. Or you can say times 2 pi r. Then done. This is the formula for the perimeter of a sector. Then we have a segment, area of a segment. Area of a segment. Segment is like this. It's part of area of a circle like this. So this part, let me draw it properly. So this part, this one is called the segment. So to find area of this segment, it's more like this. Then let me shade in blue here. That's called the segment, shaded in blue. So if you can check, from primary level, actually, we say area of the shaded part. Like if I can give an example, like this one. If you want the area of this shaded, let me shade in red, this shaded part. You say area of the whole shape minus area unshaded. Area of the whole shape, that's the bigger shape, minus area unshaded inside here, right? Just like that. So that's the same concept here. So area of the whole shape minus area unshaded. That's area of the shaded part. So the same concept applies here. Whole shape, if you can check, we have an angle theta, our radius r. Whole shape is the sector. So you can say area of segment is equals area of sector minus area of triangle. Why? Area of sector, that's the area whole shape. Then the area of the triangle, that's the area unshaded. We'll just say area of the whole shape, the bigger shape, minus area unshaded. That's area of the shaded part. In this case, is the segment. So area of a sector, how do you find area of a sector? Is theta over 360 times area of a circle. That is pi r squared. Minus area of a triangle. We can use, in this case, we don't have height. We have our angle theta, half AB sine theta. Where A and B is radius and radius. That's A and B, right? A techno, so it's the same as half r times r sine theta, which means half r squared sine theta. But this one is not necessary. Just know that half AB sine theta, right? So there's no need to cram. What you just have to know is know the area of a circle. Then you derive the area of a sector from area of a circle. Then after that, you have to know the area of a triangle. Done. Just like that. So that's for sectors. The next part. So if area of a triangle, sector, all these ones, you have them. Then you can have what is known as the total surface area of solids. Like if I can have this one. Right, so this one is a cuboid. Is it a nice one? Wow, it's nice. So this one is a cuboid. To find the total surface area of this cuboid, right, check. It has how many faces? You say 1, 2, 3, 1. Then the other face, let me shade it in blue. Then the other face down here, let me shade in black. I have three faces that I have shaded actually, blue, red, and black. So total surface area, that's the outside area of an object, everything. In this case, if you can check, the outside area of this cuboid is made up of rectangles, they makes up the outside. So you can just add the total area of these rectangles. How many sides or rectangles do we have? We have 6 of them. And if it's a cuboid, they are in pairs. This rectangle is the same as this rectangle on this side. They are equal. So you can say area of this rectangle times 2. Area of this rectangle times 2. That's the first part. Area of that rectangle times, then plus area of the other rectangle, this one down here, is the same as the rectangle up here. They are the same. So you say area of this rectangle down times 2. Then plus area of which one is left? This one on this side. It's also the same on as that one on the other side. So it will be also area of that rectangle times 2. That's the total surface area of this cuboid. Just like that, right? Just like that. Right. Then, right, this part done. Then on the volumes part. Then the volume of a cuboid is the same as a cube actually. For a cube, all the sides will be the same, will be equal. That's what makes different from a cuboid. So volume of any shape, please take note. Volume of any shape, any solid actually, is equal to cross-sectional area. Cross-sectional area times length. Then cross-sectional area is the same as base area. That's the same as the base. Sometimes the same as the face of the shape. Then length, sometimes it's also the height. It depends on how your item or your solid is like. Like in this case, for example, if I can put this one as it's a cylinder. Right. My cylinder. So to find the volume of, if you can check, this will be height. If it's like this. But now, if it's presented in another form, like let's say it's like this. Yes, it's still a cylinder, but it will be called length. That's why you can say times length or times height. So please take note of that part. So it will be length or height. Right, let's start with this one cylinder. How do you find volume of this cylinder? You say base area or cross-sectional area times height. Then the base of this cylinder, check. It's a circle with radius r. So which means we say volume of this cylinder is area of a circle times height. Area of a circle is pi r squared times height h. That's the volume of a cylinder. Done, just like that. Then let me also, we have also this curved surface area. This one, the curved part of the cylinder. Curved part. So the curved surface area of the cylinder. Please take note. We have curved surface area and total surface area. So the curved part, let's draw a net of this diagram. It's from the net. If I can draw like the net of this cylinder, I break it down. Like this, I open it up. So this is the cylinder. This one is too big. Better. If I can break this cylinder, it will look like something like this. Then if you can check, this cylinder is made up of circles. So it's a circle that has been put on top of another circle. These are circles going up. And the distance from one point of the circle to the other one represents circumference. And what is circumference? Is 2 pi r. That's circumference, or pi d. So you can say this side of this cylinder that I have broken down is 2 pi r. Then this side, this one is height. Then this one, the circle, radius r. This one is identical to this one with also radius r. Like this. So to find the curved part is this one now. That's the curved part with 2 pi r and h. So to find the area of this, it's more like a rectangle. So it will be 2 pi r h. That's the area, the curved surface area of a cylinder. Right. Then total surface area. The total surface area, it will be curved curved surface area plus area of two circles. You have two circles, this one up and down here. There are two of them. So that's the total surface area of this cylinder. So area of curved is what? 2 pi RH plus two circles is 2 pi r squared. This one represents the total surface area of this cylinder. Just like that. Done, right? So the other dimension of taking this one, like the curved surface area of a cylinder, you can say a cylinder is made up of circles that has been put one on top of the other. Right, so you can say the circumference of one circle, which is 2 pi r, times the number of circles. Number of circles are represented by the height, h. Just like that. Still to make sense. That's the curved surface area of a cylinder. Done. Right, next, we can move on to a cone. Right, a cone, it came from something like this. Wow, what type of shape is this? Right, it came from something like this. And this one is a cylinder with height h. So a cone, if we can divide, like this one, that's a cone in red. That's a cone. So a cone, if you can check, it's actually part of the cylinder. It's part of the cylinder. That's a cone. This is a cone inside there with radius, cylinder with radius r and height h. Right, so if you can check, this cone is actually part of the cylinder. This cylinder has been divided into three parts. This part is 1/3, this one is 1/3, this part is 1/3. So there are three parts, which means volume of a cone is found from volume of a cylinder. Volume is equals to volume of a cylinder, that is pi r squared h, divided by 3. So it's 1/3 of volume of a cylinder, which means 1/3 pi r squared h. That's the volume of a cone. Take note of that part. Then number 2, that's volume of a cone. Then curved surface area. Curved area or surface area of the cone is pi r l. Please don't confuse this h and this l. H is this height. That's the perpendicular height. H is the perpendicular height or the vertical height. If I can take this cone, it's like this. So it's something like this. So this will be, if the red one, this will be the vertical height. The vertical height, then this will be the radius r. So that's the vertical height. Then this part is called the slant height of a cone. A slant height is L, represented by L in most of the cases. So this, the L for the curved surface area, is the slant height, where L is the slant height. Take note of that part. That's the curved surface area of the cone. Then the total surface area of the cone. Total surface area, if you can check our cone. Right, so this one, total surface area, a cone is made up of, we have a circle down here. A circle down here with radius r. So we say curved, which is this blue one, plus the area of a circle down there. So you say total surface area is curved area plus area of a circle, that is at the base. Take note of that part. So curved is what? Pi r l plus circle is pi r squared. This will be the total surface area of the cone. Total surface area of the cone. Done. Right, moving on to another solid. It's like a bowl. So this one is called a sphere. Sphere, no height. How do you find volume? Volume is 4/3 pi r cubed. Most of the times you'll be given this volume, right? Then to find the surface area now. Surface area, right? For those who know differentiation, to find surface area, you differentiate this one. You differentiate volume, so it will be 4 pi r squared. Differentiating volume, it's more like you bring down the 3, so it's 4 over 3 times, bring down the 3, then subtract 1 to the 3. So 3 will cancel out, it's 4 pi r squared. So you get the surface area after differentiating volume. Just like that. So that's for a sphere. Then next, for a, yeah, we are done with these shapes, right? We're done with these parts. Now, the prisms. The prisms. It's a solid that can have like a triangular face, a rectangular face, or it can be a trapezoid, a trapezium face. So it can be a prism like this one. Let me put a triangular prism first. This one is a triangle. So this one's called a triangular prism. Why? Because it actually has the face of a triangle. This will be the length. That's also the height. Because this one is now like lying down, it's called length. But when it's standing vertical upwards, we call it height. So to find the volume of this now, of this prism, I'll define the volume. It's cross-sectional area, cross-section, that's the face. That's this one, it's a triangle in this case. So if this triangle actually have height, I can put my height h, and this will be the base, and this will be the base b. So I can say volume is equals to area of a triangle times length. For which area of a triangle is half base times height, then times length. That's the volume of this triangular prism. Now let's say my triangle, maybe there is an angle. Maybe I have my angle theta, then I have this A and this one is B. So I can see with the same concept, area of a triangle will now be half AB sine theta, then over times length. That will be the volume of this solid. Please take note of that part. Then the surface area of this one, it will be like this. Area of the two triangles, say this triangle times 2 plus area of this side. Please, this side is actually a rectangle, right? It looks like it's more like a parallelogram. No, it's not. So to deal with these things properly, imagine the real thing, the real shape, like it's made up of paper, then it's on the table somewhere there. Imagine the real item, then you can be able to treat it properly. It's more like even if it's a shape, if it's a photo taken in reality, you can find out that a 3D item, it will look like the shapes. The size actually, it's more like this, but it's not actually like that one. It's a straight item. It's a rectangle, right? Then this side and this side, this other side here is a rectangle, then this rectangle. So it's area of this rectangle times 2, the other side. Then area of this triangle times 2, backward. Then area of this shape down here. If you can add all these areas, then you can add the total surface area of the shape. Done. Next, we can have a trapezoid. Something like this. Something like so. This one is another shape whose face is a trapezium of height h, and this side are parallel. We call this A and B, and this will be the length. So to find the volume of this solid, you say cross-sectional area or face area times length. The face of this shape or the cross-section of this shape. Cross-section is this one. That's the cross-section. It's a trapezium. Cross-section is the trapezium. So to find the volume, you say area of a trapezium times length. Area of a trapezium, how do you find area of a trapezium? Half the sum of the two parallel sides, that is A plus B, times the perpendicular height. Then the answer that you get, say, times length. That will be the volume of this solid. Just like that, I'm sure you can understand. Please like, share, and subscribe to this item. Then watch out for another video that you have like questions worked out from past exam papers. Thank you.